When you are tasked with upgrading the safety of a piece of heavy machinery or, refactoring a critical failure point in some massive system, you usually expect the solution to be a major, highly visible overhaul.
Right, you expect a proportional response, like you anticipate seeing new safety guards installed or completely rewritten protocols, maybe an entire module just getting swapped out.
Yeah, exactly. But when you step into the world of software development and specifically language design, that sense of physical proportion completely vanishes.
Oh, totally. It's a completely different scale.
I mean, we are looking at a landscape where the difference between a program functioning perfectly and utterly exploding in a production environment is down to a single tiny punctuation mark.
It is a literal character change, just one byte of difference in the source code that dictates whether a system is robust or, incredibly fragile.
Welcome to the deep dive. Today we have a highly specific, honestly fascinating source to unpack with you.
Yeah, this is a really good one.
It's an excerpt from a blog post by a developer named Ang. The post is titled Notes on Haskell Programming, Part 155, Safe UTF-8 Decoding with decodeUtf8. And this was published on June 6th, 2026.
And this specific excerpt gives us this brilliant window into the actual trenches of software maintenance. Ang is detailing what they describe as tiny refactoring changes within a code base.
Right. And our mission today is to thoroughly explore this one specific change Ang made.
Just this one tiny swap.
Exactly. We are looking at a swap within a module called data.text.lazy.encoding. Ang takes a function called decodeUtf8 and replaces it with decodeUtf8.
And that second one has a single quote at the end of it, which in this context is pronounced decodeUtf8 prime.
Okay, let's unpack this.
Okay.
Because to me, swapping these functions, it's like replacing a car engine with one that looks exactly the same, right? It literally just has a tiny sticker on it. But suddenly, because of that sticker, the car is completely crash-proof.
That's a great way to put it. The underlying mechanics of what that tiny prime symbol actually does to the compiler's behavior is, well, it's what makes this so critical to understand.
But why was the original engine, the original function, so dangerous in the first place?
Well, to understand how Ang implemented the safe version, we really have to look at why the original wiring was so flawed.
Let's do that. Let's look at the original state of Ang's code. Before this refactoring, Ang is reading a file.
Right. Referred to in the code as simply content.
Yeah, content. And the goal is to translate that raw byte data into usable text. So the original line of code simply said, let text content equals decodeUtf8 content.
Which is, just a very standard assignment. You're telling the program to evaluate the right side and bind it to the variable on the left.
But wait, if Haskell is a purely functional language, and it prides itself on mathematical precision and this incredibly strict type system, why is a core standard library function like decodeUtf8 allowed to harbor a hidden crash?
It is a bit ironic, isn't it?
It really is.
Yeah.
Because Ang points out that if this function encounters a text file that is not perfectly valid UTF-8, it throws a runtime exception.
Right.
Wait, so the runtime exception isn't just a minor hiccup, right? If I'm understanding this, it means the program literally explodes while the user is actively using it.
Yes, exactly. The thread dies instantly. It is a total worst-case scenario.
It's like having an overly dramatic translator. You hand them a document, and upon reading a single word they don't recognize, they don't ask for clarification, they just faint on the spot.
That is exactly what's happening under the hood, and it's really a historical tension in language design.
How so?
Well, standard libraries in many immature languages were originally written with an optimization for the happy path.
The happy path meaning assuming everything just goes right.
Exactly. The assumption was that the developer would validate the data before it ever reached the decoding stage. So the function's type signature essentially lies to you.
Oh, wow. Lies to you how?
It claims it takes a byte string and returns standard text. It makes absolutely no mention of the potential for failure.
So because the type signature doesn't warn you, the compiler thinks everything is totally fine.
Right. The compiler just gives it the green light.
You compile your program, you deploy it, and the moment a user uploads a file with a single corrupted or malformed byte, the function panics.
Yep. It throws that runtime exception.
And because the compiler didn't force you to prepare for it, the application state becomes totally unhandled. The operating system just steps in and kills the process.
From a systems perspective, throwing an implicit runtime exception for a highly predictable I/O issue like bad text encoding is an anti-pattern.
Because it transforms a localized data error to a total application failure.
Exactly. You cannot build a highly concurrent, reliable system if your foundational parsing tools are actively hiding their failure modes.
Which is exactly why Ang had to intervene and refactor this. To get away from that hidden failure mode, Ang swaps out the dangerous function for the safe one.
They introduce the prime symbol.
Right. Changing it to decodeUtf8. And in Haskell, appending that single quote, that prime to a function name, is a naming convention, right, to indicate an alternative version of that function.
Yeah, language designers use it as a shorthand. It's a way to say, this function is deeply related to the original, but we have altered its behavior or its return type in some specific way.
But this brings up a massive point of friction that Ang highlights in the post.
Oh, the inconsistency.
Yes, you would think in a strict mathematically driven language, a naming convention would be universally consistent. But Ang specifically notes that the use of the prime symbol is actually rather inconsistent across the language ecosystem.
And that inconsistency is a stark reminder that programming languages are, ultimately human creations. They're bound by evolving community conventions rather than pure logic.
Here's where it gets really interesting, though. In a world of highly precise coding, this one symbol is basically a wildcard.
It really is. Ang details the different flavors of this convention. Sometimes you append a prime to a function to indicate it is a stricter version.
Okay, so what does stricter mean in this context?
For example, it might evaluate data immediately rather than being lazy about it.
Right, and other times, Ang points out it denotes an internal helper function.
Yeah, a function that's doing the duty work behind the scenes and isn't necessarily meant for the end user to call directly.
And then we have the third variation, which is what Ang is dealing with today.
Right. In the context of decodeUtf8, the prime specifically signifies a safer and robust alternative.
It's the version of the function engineered to intercept the failure without crashing the runtime.
Exactly.
But wait, if I'm a developer trying to maintain a complex or legacy code base, and I see a function called foo and another called foo prime, you're telling me the language provides zero compiler-enforced guarantee of what that prime actually means?
Zero guarantee.
I just have to guess if it's strict, internal, or safe.
Well, you don't guess, but you have to consult the documentation every single time, or literally dive into the source code of the library itself to figure it out.
That sounds incredibly tedious.
It is. It shifts the burden of understanding from the compiler directly onto the cognitive load of the developer. Like you said, it's a wildcard character.
In an environment where a misplaced space or incorrect indentation can completely break a build, having a piece of ambiguous punctuation dictate the safety of your system just feels incredibly contradictory.
It's definitely a quirk of Haskell's evolution.
But let's table the ambiguity of language design for a moment, because I really want to drill down into the mechanics of how this specific prime function actually creates safety.
Sure.
Because Ang didn't just add a prime and leave the rest of the structure alone.
No,
Right?
not at all. The structural change is the entire point. When you swap in decodeUtf8, the return type fundamentally changes.
Right.
The original function, as we discussed, returned raw text or it violently crashed. The prime function returns something called an either type.
So what does this all mean? If it doesn't crash, does it just silently swallow the error and pretend everything is fine? Like hand you back corrupted garbage data?
No, it does the exact opposite of swallowing the error.
Yeah.
Because it returns an either type, the programmer is forced to handle the decoding error explicitly.
Ah, so this is where the compiler stops being passive and starts becoming an accountability partner.
Exactly. When a function returns an either type, its type signature is finally telling the truth.
No more lies about a happy path.
Right. It explicitly declares that the computation has two possible outcomes. By convention, it returns a left containing the error information. In this case, a decoding exception.
Okay, left is the error and the other outcome.
Or it returns a right containing your successfully decoded text.
So it literally hands you a defined container. You get a box that says either there's an error in here or there's text in here, and you can't just run with that container blindly.
The compiler will explicitly block you if you try.
Really, it just stops you.
Yeah. If you try to pass an either type into a function that expects standard text, the compilation fails. You cannot execute the program until you write code that safely unpacks that container.
Oh, wow. That explains the structural teardown in Ang's code diff then.
Yes. Ang couldn't just keep the old assumption. They had to completely delete that original let assignment we talked about earlier.
Because you can't just say let text content equals decodeUtf8 prime content.
Exactly, because text content is no longer just text.
It's now this Schrodinger's box of potential failure or success. You have to open it.
And you open it using something called pattern matching.
Right, which Ang achieves by introducing a nested case statement. I love how this looks in the code. The new line reads, Case decode UTF-8 prime content of.
It literally creates a forced fork in the road at compile time.
By using pattern matching against the inner type, Ang is forced to map out both states.
The developer must explicitly write a block of code for what the system should do if the left error case is triggered.
So maybe that means logging a warning or skipping the corrupted file or prompting the user for a new one?
Right, and they must write a separate block of code for the right success case where the valid text is actually processed.
It is a profound shift in engineering philosophy.
It really is. You are moving from optimistic, happy path execution where you just hope the data is clean to exhaustive state handling.
The original code was essentially living in denial about the realities of file inputs.
Yeah, the real world is messy. The refactored code acknowledges that failure is a standard, expected state in computing, and it forces the developer to architect a response to it.
So instead of the program spontaneously crashing, the either type hands the developer a branching path, one for success, one for failure, and demands they deal with both.
You are shifting the management of the error from a catastrophic runtime event, which, impacts the user and the stability of the operating system, to a compile time guarantee.
The compiler ensures that your application has a defined roadmap for failure before it ever reaches a production environment.
Exactly.
Zooming out from the Haskell code for a second, even if you never write a line of code in your life, this deep dive is a masterclass in anticipating failure.
Oh, absolutely. The concepts translate anywhere.
The original function represents hoping for the best, just assuming you'll get perfect UTF-8 data. But the prime function represents preparing for reality. It's about handling the error.
Building systems that bend instead of break.
Exactly. Whether in software, business, or just daily life, you need systems that bend instead of break when they encounter bad information.
And the robustness of a system isn't defined by its ability to process perfect data. It is defined by how elegantly it handles malformed data.
Well said. Ang's refactoring takes a system that was fundamentally brittle and, through the power of pattern matching, makes it flexible and secure.
It really makes you appreciate the cascading impact of a single line of code.
It really does.
Yeah.
But as we wrap up today, I want to pull back to that underlying tension we discussed earlier.
The inconsistency of the prime symbol itself.
Yes. We have a standard library that requires developers to bolt on a somewhat ambiguous naming convention just to achieve basic I/O safety.
It leads to a really vital question about the life cycle of our software infrastructure.
Right, because if a programming language feature specifically designed to provide an alternative doesn't have a strict universal rule for what that alternative is, does that inconsistency ultimately create a brand new type of risk?
That's the million-dollar question. If the foundational tools of established programming languages are riddled with these unsafe, optimistic assumptions from a decade ago, what is the sheer cost of migrating away from them?
Are developers just doomed to indefinitely patch legacy APIs?
Think about the scale of it. We are slapping prime symbols and safe wrappers onto fundamentally fragile libraries across millions of lines of code worldwide.
It's like putting a Band-Aid on a foundational crack.
Yeah. Does the industry continue to accept this massive technical debt, constantly relying on developer discipline to just, remember to use the prime version?
Or does there come a breaking point?
Right. A point where language maintainers have to accept the catastrophic cost of rewriting standard libraries from the ground up, deprecating the unsafe originals entirely.
And breaking backwards compatibility for the sake of true systemic safety.
It's a daunting prospect.
It's a massive architectural question to leave you with. If the foundation of the ecosystem is built on implicit crashes, are we genuinely making our system safe? Or are we just adding nicer circuit breakers to a house with fundamentally faulty wiring?
It's definitely something to mull over.
Think about the sheer scale of that technical debt the next time you spot a tiny punctuation mark in a commit history.
Thanks for joining us on this deep dive.